today we're going to take a look at a few more properties of angles and a few more definitions of angles, angle relationships. So first, okay, let's just define some of these. So vertical angles are angles. The easiest way to define vertical angles are angles that are directly across from one another. So what that looks like. Okay, in this diagram over here, was angle EFI and GFH would be an example of vertical angles. Okay? Angles that are directly across from each other. Okay? Now, another important idea with vertical angles, and we'll do a lot of practice problems with this idea, is that vertical angles have the same measure, okay, or are congruent. Okay, vertical angles have the same measure or are congruent. So, I gave you one example here. Somebody look at this diagram and give me another example of vertical angles. There? IFH and EFG. Sure, that would work. Okay. What about another one? Like
CBD and
yeah, that one's not labeled. But yeah. So CBD and that one?
Yeah.
So? This one here? And ABC? Bless you. Yeah, that would work as well, right? These two right angles. Okay? So vertical angles share a common vertex. Right? I mean, there's a technical, okay, two non-adjacent angles formed by intersecting lines. Okay, but in terms of just visually seeing what's going on, they're angles that are right across from each other, right? And they are always going to be congruent. Adjacent angles. Adjacent angles are angles that are right next to each other. In other words, they share one common side. Okay, so an example of adjacent angles could be like CBD and EBD. Okay, two angles that are next to each other that share a side. Okay, that would be an example of adjacent angles. So give me another example. Over here. Oh, over here. Oh, like this one? Is that what you're saying? Yeah. Right. You could say CBD and ABC, right? They would share one side. Right? That's adjacent angles. Right? A linear pair, then, is a special type, a special type of adjacent angles. Right? So a linear pair is adjacent angles that make a straight line together. Okay, so for example, EFG and HFG. That would be a pair of adjacent angles, right? They share one side, and together they make up a straight line. Okay? A key property for a linear pair, right? They will always add to 180 degrees. Okay? The measures of two angles in a linear pair will always add to 180. So if I tell you that this one's 120, that means this one's 60. Right? They have to add to 180. Right? So give me another example of a linear pair here. Great.
ABC and CE.
Sure. ABC and CE. Yep. Those are two right angles. They would make a linear pair. Right? They would add to 180, and together they would make up a straight line. Right? Then the last two properties that we're going to look at today are supplementary and complementary. I think you guys have heard these terms before. You remember what they are?
Nope.
Great.
Supplementary is 180 degrees. Complementary is 90 degrees.
All right. Supplementary angles are angles that add to 180, and complementary are angles that add to 90. Does anybody have a good trick for remembering that? Okay. Compliments are right. You should give compliments. Give me a compliment.
Like your
Oh, stop. 90 degrees. Alright, it's stupid, but you'll remember it. Okay? If somebody gives you a compliment, oh, stop it. Makes a 90-degree angle. Alright? So complementary are angles that add to 90. Supplementary are angles that add to 180. Alright? Any questions on these properties here? Okay, so we're going to use these properties to solve some problems here. Okay, so vertical angles, we'll definitely use that one. If we're looking at a pair of vertical angles, we can say they are equal to each other. A linear pair, add to 180. Supplementary angles add to 180. And complementary angles add to 90. All right, so I guess before we actually solve some problems, let's just practice recognizing these properties here. All right, so we'll take a few minutes here, and you guys try these exercises. Okay, and there's multiple examples of these, right? Name two adjacent angles. Okay, there could be any pair of angles that share a side in the middle. Okay, there are many correct answers there. Two acute vertical angles, two supplementary adjacent angles. So let's take a few minutes here and see if we can name these different relationships. All right, so here's some sample answers. Okay, I said, there's lots of different correct answers, so these aren't the only correct answers, right? But these are some examples. What questions do we have? Like,
how did you get numbers?
It says find the measures. Find the measures of
angles. Wait, how do you get numbers? Dude, I could have just go on that, like, read off.
Yeah, so find the measures of two complementary angles if their difference is 18. How would we set that up and solve it?
180.
Wait, say that again?
No.
Okay. Aaron?
X minus 18 equals 1. And then x plus y equals 90. And then you substitute the one that's x minus 18 into y. And then you solve that. And then you get what x equals. And then you come back to the x plus y and substitute that in.
That would work perfectly. Aaron set up a system of equations and solved it, right? And we would end up with 36 and 54. Okay, maybe a visual way to look at this. Okay, it says complementary angles, right? So I know they're going to have to add to 90. Well, we can say if their difference is 18, right? We can say that one of them is x and one of them is x minus 18. Okay, which is essentially what Aaron did. He just used more algebra than the visual geometry. Absolutely, perfectly fine. Right? But if we want like a geometrical perspective, okay, this is essentially what we did. Right? So then we would just say x plus x minus 18. Right? Adding these two angles together gets me 90 degrees, right? Which is the same thing we ended up with down here, doing it more algebraically. Right? And then solving this equation, we would get one of the angles. I think we would get the 36, and then plugging it back in for the other angle. Or no, we would get the 54. Yeah, we would get the 54 solving it this way, and then plugging it back in here. 54 minus 18 gets me the 36 for that one. Right. You okay with that one? Other questions on recognizing angle relationships here? You all right? Good. All right, so on the back, we are just going to do some algebra, okay, setting up and solving equations using these angle properties. Right, so we have to know that complementary means they add to 90, supplementary means they add to 180. A linear pair also is the same as supplementary, meaning they add to 180, and vertical angles are the same. Okay, we're going to use those ideas to set up and solve equations. Okay, now we also have to understand what perpendicular means. Perpendicular means that they meet at a 90-degree angle. Right? The symbol for perpendicular is this right here. Okay, I'm not sure if you guys have seen that symbol before. Okay, but it just looks like an upside down capital T. Right? This symbol means perpendicular. Okay, so if you haven't seen that before, jot that down. All right, this means perpendicular. This is the symbol for perpendicular. Right. So, if we're looking at example 1 here, okay, what I'm told is that DZ and ZP are perpendicular. Okay? Perpendicular means they meet at a 90-degree angle. So if I know that they meet at a 90-degree angle, and I'm given expressions for the two smaller angles, for DZQ and PZQ, how could I set up an equation here? Like,
dx plus 5 and then add that to 3x plus 1 equals 90.
Yeah, right? We're going to add these two expressions together and set that equal to 90. Right? So 9x plus 5 plus 3x plus 1 equals 90. So go ahead and solve that real quick. We get 7. All right. Feel okay with that? All right. So let's jump down here then, okay, and take a look at a few more questions like this. Okay. Now, within these questions, okay, we may have to use, in the first one, okay, we're again using perpendicular. Okay, but then in some of the problems down here, we'll have to use ideas of vertical angles, complementary angles, supplementary angles, a linear pair. Okay, so let's take a few minutes. Let's take a few minutes here and try some of these. All right, how did we do with number 1 here? Okay, with the 2 variables here. Okay. So whenever we have multiple variables, right, we can't set up one equation. We would have to set up multiple equations, right? So we would have to deal with the x's first, okay? So we could say 5x plus x is equal to 90 degrees. X equals 90. Solve that. And we should get 15. Okay, then separately, we could say 9y plus 18 equals 90 degrees and solve that one. Right? We could get 8. Just make sure you're not trying to combine those into a single equation. All right? I know you probably didn't get all of these done. That's all right. Okay. Okay, but are there any questions on the ones that you did complete?
Number 2.
So EBF and FBC, so they should add to 90.
It's ABF, which is
It's EBF.
yeah.
EBF and FBC.
Oh, you're right.
Yeah. So here's the homework.